In this question, the distribution of the daily wages of 50 workers of a factory are given. A table is given. In the first row, daily wages in rupees are given. That is the daily salary of the workers. And in the next row, the number of workers are given. If we observe this column, 12 workers are getting the salary or the wages in the range of 500 to 520 per day. They are getting the salary 500 rupees to 520 rupees per day. 14 number of workers are getting the salary or the wages in the range of 520 to 540 rupees. Similarly, the rest of the table is given. 10 workers are getting the high salary 580 to 600 rupees. Maybe they are having the higher number of qualification or they are more experienced as compared to other workers. In this question, we have to find the mean daily wages of worker of the factory by using an appropriate method. Let's see which method we have to apply and how to apply. Let's convert the column into the rows. The first, it is the range. The second, it is the frequency, which is Fi. Okay. The first step, we will convert the range into the observation, which is Xi. How we do that? We find the midpoint. Here, what will be the midpoint of 500 and 520? It will be 510. That is the midpoint of 500 and 520. Either you can use a calculation, that is upper range plus lower range upon 2, 500 plus 520 upon 2. That will comes out to be 510. That is the midpoint of the range. Similarly, we will calculate the midpoint of all the ranges. 520 to 540, it will be 530. Next, it will be 550. Next, it will be 570 and 590. Got it? We got the observations, that is Xi. Next step, either we can calculate Fi into Xi, then we can add all the Fi into Xi and apply the first method, that is a direct method, or we can go to the next method. Here the observation, that is 510, 530, 550, these are large numbers. You have to multiply Fi into Xi, that is 12 into 510, that will again gives us a large number. Adding all those numbers will be slightly difficult. So we will not use the direct method. We will jump to the second method, that is the assumed mean method. Why we are doing this? To avoid the large calculation. Okay, let's see. In the end, you will understand it more why we have used that. So how we approach in the assumed mean method? We will find one of the observation which is the middle of all the observation, that is Xi, and we will subtract that assumed mean from all the Xi to get deviation, which is Di. Let's see what I am saying. Firstly, let's find the middle term of all this observation. Here the middle term is 550. Note that you can take any of the value as the assumed mean, which is A. Here we have taken the middle value, so our calculation became much easier. Let's see. Let's take assumed mean A as 550 and we will subtract 550, that is assumed mean, from all these values of the observation, which is Xi. 510 minus 550, which is minus 40. 530 minus 550, which is minus 20. 550 minus 550, which is 0. Then 20, then 40. This is a deviation which we denote as Di. Next, now we are having again two options. Either we can use the assumed mean method, in which we have to calculate Fi into Di, or we can move to the next method, that is a step deviation method, which we can only apply if the class size is a common factor of the deviation. Let's understand this. Here, what is the class size? 500 to 520, the class size is 20. If you observe all the ranges, the class size is 20. Like 520 to 540, we are having 20 numbers. 540 to 560, we are having 20 numbers. So the class size H is 20. And we can easily divide the deviation, all these numbers, with the 20. Like 40 by 20, it is 2. 20 by 20, it is 1. Like 0 by 20, 20 by 20, 40 by 20. We can easily divide all the deviation values with the class size. In this case, we will go with the third method, that is the step deviation method, when we can easily divide all the values of the deviation with the class size. Or class size is a common factor of all the deviations. Both the things are same. Got it? Here we will go with the next method, that is the step deviation method. Let's divide the deviation di with the class size, which is 20, that is h. So minus 40 by 20, it will be minus 2, then minus 1, 0, 1 and 2. We got very simple value like 2, 1, 0, 1, 2. If we compare this with the observation 510, 530, 550, these are very large values. We can also compare ui with di. Here di is still larger like 40, 20, minus 20, minus 40. Ultimately, our UI, the value of UI is very simple. Our calculation became very simple. So we will go with the third method, that is the step deviation method. This is the formula. In the formula, we have to calculate sum of Fi into Ui. For that, we have to calculate Fi into Ui for each row. Let's do so. Let's multiply each row, like 12 into minus 2, it is minus 24. 14 into minus 1, it is minus 14. 8 into 0, it is 0. 6 into 1, it is 6. 10 into 2, it is 20. We got Fi into Ui. Let's add all these values. We got sigma Fi into Ui. That is the sum of Fi into Ui, which is minus 12. Got it? Let's also calculate the sum of Fi, which is 50. So we got sigma Fi as equal to 50. Let's use the formula here. A, that is the assumed mean, it is equal to 550. H, that is the class size, is equal to 20. Sum of Fi into Ui, it is minus 12. Sum of Fi, it is 50. Let's put the value. On solving, we got the answer as 545.2. That is the mean average weighs. 545.2. That is the answer. Got it? And why we have used this specific approach, that is the step deviation method, because our calculation became much easier. Okay, we have done with the question number 2. So students, we have done with this lecture. Hope you have enjoyed the lecture. If so, please like, share and subscribe. And also check out the description for various resources related to class 10, like the continuing lecture, the lectures related to other topics, and the PDF of the formula list. All this in the description, check it out. So that's it for this lecture. Thank you very much for being with CREATA Classes. Have a great day. Bye for now.